The protocol ISIS is also another link state routing protocol. But there are very important differences that we should know. If you know OSPF, I tell you, you really know ISIS. But there are big differences. For example, there, the main building block is LSA. We call it as link state advertisement. Here, it's LSP, link state protocol data unit, or link state packet. In short, you can say PDU or packet. LSP, the P stands for PDU, protocol data unit, which is just carrying the link state informations. But you can also call it as packet in short. LSA is link state advertisement in OSPF. Here LSP is link state packet or link state protocol data unit. The other difference, very important difference that I was talking about on the other day is the metric. Here the metrics are automatically calculated according to the bandwidth on the link. Whereas where in OSPF, the metrics are calculated automatically based on the bandwidth on the link. Whereas in ISIS, whether it is a gig Ethernet or fast Ethernet, that doesn't matter. The cost remains the same. The cost is 10. The fixed cost for each link is 10. So whenever you have like 10 links between source and destination, the cost is going to be always 100. The cost won't vary based on bandwidth. The cost will vary only based on the number of links, wires. How many hops the router needs to take your traffic to the destination. How many hops? If I have 10 hops, then cost is 100. Each link cost is, no, what is each link cost? 10. Each link cost is 10. As a result, if you have 10 hops, then it is 100. And the other main difference that we saw is in a broadcast environment in OSPF, there is a DR BDR election. Whereas in ISIS, there is only DR. We call it as IS, this designated intermediate system. The word router need to be replaced with IS, intermediate system. Now, keeping all this in mind, let's get into this chapter. OSPF and ISIS, even though both are link state routing protocol, ISIS is more stable than OSPF. Yes, this is more stable. This is the reason why majority of ISP will have ISIS. I don't know, now the story is changing because a lot of engineers today don't know ISIS. So they keep recommending OSPF to the company and they switch to OSPF. It is because of the lack of knowledge. But truth is, ISIS is more stable than OSPF. Yeah. And early days, the US government was also making it as a mandate that every service provider should have ISIS. And ISIS was modified to support the industry standard OSI and the protocol IP. Meaning, ISIS is not an IP protocol originally. ISIS is not even the supporter of OSI reference model. Why? Before OSI became standard, ISIS was there. See, everyone, when we learn networking, we think that OSI is the standard from where we need to start. So we consider OSI reference model as the fundamental of networking, isn't it? See, for a lot of troubleshooting, people with a good OSI knowledge can troubleshoot more problems easily. Those who have the experience with Wireshark, they do better troubleshooting than a non-experienced with Wireshark, which means the OSI knowledge gives them uh, the hint to where to check when there is a trouble. But this ISIS is much older than that standard. If you ask me OSPF, we'll say it's a layer 3 protocol. Likewise, ISIS, the initial version, cannot be said. You cannot say that it is layer 1, layer 2, layer 3, because it will not stick into OSI framework. Wait, I'm coming. So this ISIS was Adangada Kalai Pondru on those days. You will not be able to control, or you will not be able to uh, um, you will not be able to predict with the OSI knowledge on those days. On those days, ISI, the initial version of ISIS was not that easy to understand. The reason is it is not as per the standard. But it was a wonderful routing protocol, the oldest routing protocol we can say, ISIS. OSPF and all came much later. OSPF came later. OSI also came later after ISIS. So ISIS is such an old protocol. And then there was no IP support also. There was different addressing method on those days. You might have heard about IPX, Apple Talk, and much more. So likewise, something different was there, using which the devices were identified. So there was no IP address. So later days, as it is written here, the US government forced to alter this ISIS to support this OSI and IP. You understand? In order to support IP and OSI, ISIS was altered. Alteration was done to ISIS. So the version that we are having is not the original version of ISIS. It's the modified IP version of ISIS. See, this is the reason why ISIS is gaining popularity. What? You can tune it. See, ISIS is like this. ISIS is like this. Now, if you want it to be a car, then you add something like this and you put the seats. It becomes a big van. If you want this to be a lorry, then what you do, you fit something like this and it becomes lorry. And if you want, you lost your house, sorry. Right? Now it can become a bus. It can also become a camper van. You can have your kitchen inside, bedroom inside, everything inside, and you can live there. ISIS is like this, but OSPF is like Mr. Bean's car. It is already a small car. You cannot further modify it. It's one small car. Have you seen Mr. Bean's green color car? Ah, OSPF is only that much. ISIS is like a heavy engine. That's all. Depending on your requirement, environment, you can modify it and use it. So this is modified now for IP. ISIS is modified now for IP. Now the reason why ISIS is gaining popular is not only with IP, you can use it with anything else. For example, in Cisco data center, we have a feature called fabric path. You know, okay. If you see fabric path underlay protocol is ISIS. But do we give any IP address there? No. We don't configure any IP address. It's a layer 2 technology. Fabric path is a layer 2 technology, which provides you the ECMP advantage. The benefits of ECMP in a layer 2 level. Usually in a layer 2, because of the spanning tree, you will lose half of your resource. Spanning tree will block to prevent loop. It will block, so only half of the resource will be in usage. Other half will be blocked. Fabric path says, don't worry. I can provide you all the lines active with no loop. How is that possible? It is an encapsulation. Every switch has got a fabric ID, like an IP address you have, like in ACI you have VTAP address, here you have fabric ID. It's like a MAC address, which is dynamically generated by every switch. Using the fabric ID, these devices will discover each other. And it is only by using the fabric ID, the paths, the forwarding tables are built. As a result, there is no need for spanning tree protocol, STP. Fabric path brings the layer 3 advantage into layer 2. It is all because of ISIS. If no ISIS routing protocol, this is not possible. You see, there is a routing protocol which never uses IP address here. Yeah. So ISIS is highly resilient. The original designed ISIS as the IGP, it was for CLNS, not for IP, it was for connectionless network service. That was the old method. Old instead of layer 3 IP protocol. Today we have IP now, everything is IP. Everything is IP. See, only Cisco provides this deep, in-depth knowledge of what is IP, CLNS, all this stuff. I recently was there with Palo Alto guys. They claim to be content developer in Palo Alto, but they really don't have in-depth knowledge of IP protocol number, TCP protocol number, nothing. Mundus. but they sit in the top level to identify trainers. I'm surprised. And whatever they speak, if you say yes, then you will be selected. If you talk from your experience, oh, for them it is allergic. Tomorrow he will come and take my place. So we should not encourage this guy. You know, and instead they can go study and come. How long they will beat around the bush? I don't understand. Anyway, the silly behavior in a grown up I've seen. It is because lack of knowledge. Cisco, I appreciate. I'm very happy that I started with Cisco. I got more the fundamentals, the foundations very well. This is like that, one of that. CLNS is a very ancient layer 3 protocol. Now we have IP. So it is a modified version. The older version of layer 3 protocol, which is called as connectionless network protocol, CLNP or CLNS, is modified today for IP. ISIS uses CLNS address to identify routers and build the LSDB. You see, in IP, if we take OSPF as an example, the router ID is the one which is helping you to build a LSDB, link state database. ISIS uses a CLNS address. That is what going to be used as the identification for the router. The reason why I'm emphasizing on this is you will see me configuring net ID. When we configure ISIS, we configure a unique identification on each router called net ID. Net ID composed of three main components. One is area ID, second one is the system extension ID, and then the end selector. For IP version of ISIS, end selector will be always 00. But we will be providing a unique ID called system ID on this net ID. This is what the CLNS uses as the address to build LSDB. We will see this thing in lab very shortly. Now, as you already know, it's a link state routing protocol, and this supports VLSM, and it uses Dijkstra's algorithm. And you know about Dijkstra's algorithm, the binary tree algorithm, which is going to calculate the cost by summing up, by adding the path cost. And now this is really a fast convergence protocol because it maintains the database in the router. Each router will maintain a local database. Each router will maintain a local database. So when a route goes down, when a primary route goes down, immediately an alternate path will be promoted to the routing table. Yeah. See, we call this as advantage today, but when you go to SD-WAN, the story changes. The complete database is not local to the router. It will be in the cloud with vSmarts. vSmarts will decide the best path and push the information to the data plane, and data plane will start forwarding the packet accordingly. All right. Now, instead of IP address, they had another ID. That IP, here we are using IP protocol, so you call it as IP address. When you have IPX, then it is IPX address. That see, um, every protocol is built with a standard. For IP, you need a 32-bit address. If it is IPv6, you need 128-bit address. Likewise, the olden days protocol was structured in a different way, so the size differs. The size was different. See, how do you identify a device with IPv6 address? The same way they were identifying device with some different address, IPX address. Apple Talk was having different number system was different. Sometimes it was using hexadecimal, sometimes it was using binary. That is how it is. Early days to identify a house, post box number was used in India. Post box number. We don't want to give our address, so we used post box address. We go to post office and say, "This is my address. Give me a number, post box number." They will take a money annual subscription. They will give you a number. That number only you will give to all your friends. So whenever they send a letter to Jayachandran, post box number 123, Bangalore. That's all. Post box number 123, post office knows the original address of 123. But today that is not the scenario. Likewise, no, it's just an ID. Okay, now like any other protocol, any other IGP protocol, but don't compare RIP to this. RIP don't send hello packet. I mean, ISIS, like OSPF, ISIS also uses hello packets to establish adjacency. And I said LSP stands for Link State Protocol Data Unit, or you can say Link State Packets. This is what exchanges the link state information between neighboring routers. Now, what is the address to which hello packets are sent? If you take OSPF, we have a multicast address, isn't it? A layer 3 multicast address. What it is? OSPF 224.0.0.5. So if you see down here, I have added a note. We have two type of adjacency using the hellos. It establishes two type of adjacency. One is within area, and then another one is between area. For L1, which is within area, this is the multicast layer 2 multicast address. It's a layer 2 multicast address. With this only the adjacencies are formed. To this address only the hello packets are sent. And for L2 adjacency, you see last number is 15. Here it is 14. So you just remember this much, 14 and 15. All right. So it's a layer 2 address. Don't forget. It's a layer 2 routing protocol. It's a routing protocol that works in layer 2 level. This is very important difference. Nice point. ISIS protocol works above layer 2. Next to IP. Whereas OSPF works on top of IP. So this is layer 2, but because it's a routing protocol, they use the word above layer 2, which means it is below layer 3. That's another meaning of it. That's why, to keep it simple, I call it as layer 2 protocol. Whereas OSPF is a layer 3 protocol. Another main difference is routers of OSPF may be a member of multiple areas Whereas the routers of ISIS cannot be a member of multiple area, just one area. You will understand when we see some picture. I'll take you there later. Now let's see the differences here. The first point we saw, top of IP, above layer 2, next to IP, and then the routers on multiple areas. This is on one area. Here you have DR and BDR, here you have only DIS. Here you have a virtual link support. Here there is no need for virtual link support. That is why there is no virtual link concept. There is no need for virtual link. You will see that soon. Now, if you want to extend the OSPF, meaning OSPF is supporting ABC features, but if you want OSPF to support more features, which is not default, you have opaque LSA 9, 10, 11, opaque LSA. Have you seen that? Opaque LSA in OSPF can be used for making OSPF to do some additional job for you. For example, segment routing. Segment routing needs to carry a label in OSPF. OSPF needs to carry segment IDs. By default, OSPF is not designed to do that. By default, OSPF don't carry any label. But you can use this opaque LSA and extend the support. In ISIS also we do that using TLVs. What is TLVs? Type length value. It is nothing but feed. So don't get confused with these terms like type length value. What is this type length value? It is nothing but fields in the header. By adding some extra field, you can have extra features. And then in OSPF we have packet types. Here we don't call it as packets, we call it as TLVs or PDUs. Here also you have more granular TLVs. OSPF, small packets, small changes, ISA, small changes. Entire LSP is shared. Label switch, PDU. Sorry, link state PDU. The entire PDU is exchanged whenever there is a small change. Whereas in OSPF only that change alone will be distributed. I'm looking for those multicast address differences in the table, but they have not kept it. Okay, a few more things. Here we call router in OSPF, and ISIS we call it as IS. Here we call link, here it is circuit. Packet PDU. DR DIS. BDR, there is no backup disk. LSAs, LSP. Hello packets, IHHPD. See, H means hello. IHH means intermediate hello. Why it is IHH? No, it is not IHH. IHH. IIH. I think they have made mistake. So it is not IHH, it is IIH. Intermediate system to intermediate system. The two I stands for ISIS. And then hello, IIH. Intermediate system to intermediate system, hello, PD. And then here we say database description, DBD. Here the database description is called as connectionless, the connection CSNP. It is coming, CSNP, the actual abbreviation. If I say something now, then I may make a mistake. So let's wait for that. But what it is, it's a summary of the big database. CSNP. What is it? CSNP? We have it here. CLNS, CSNP. You see, connectionless network protocol. Connectionless network protocol. No, this is not the one. I want C. This is CL, and here we CSNP. CSNP is coming when we talk about updates. CSNP is here. Complete sequence number PDU. Okay, so which is nothing but the nutshell. Right, we have in the consecutive chapters, coming chapters, all those things in detail. Okay, so complete sequence number PDU, meaning it is DBD, sorry, it is LSDB in a summarized form. Here we call it as areas, here we call it as subdomain. Here the backbone area is a transit area, whereas here L2 subdomain is the transit. We will talk about that when we do the lab. We will have a very big clarity in this L2 subdomain. See, we don't have backbone area at all. There is no backbone area in ISIS. We do have areas, but there is no backbone area. Any area can be a transit area, but provided that area needs to have a L2 adjacency along the path. See, here non-backbone areas we call, where here we call as L1 areas. L1 areas, and then L2 areas. You can say level 2 areas. Level 2 areas can be any area number. Area number doesn't matter, whereas here it is area 0 only can be a backbone. Here we called as ABR. ABR will be a member of multi areas, right? Area 0 and some other non-backbone area. Whereas this L1, L2 router will not be a member of multi-area. It will be a member of only one area, but it will run two adjacency, L1 adjacency and L2 adjacency. L2 adjacency is to form adjacency with other area member. L1 adjacency is to form neighbor with the own area member. Next is ASBR. ASBR, we know it is between the autonomous system where we do redistribution. Here it is called as NEIS, any intermediate system. Right. Still, I'm not happy with these differences. I'm looking for that multi-guest reference, which is not here. Anyway, we saw the differences already. The multi-guest address that OSPF uses is 224.0.0.5 and 6. ISIS uses two different layer 2 addresses. One is this one, 14 for L1 adjacency, 15 for L2 adjacency, and L2 distribution of LSPs. Okay, now you see, this is what the important story. You see, for these routers to share routes, L1 adjacency is more than enough. L1 is for the member of same area. And if you notice, this router is not in the border, it is within the boundary, it is within, inside. It is inside the border. What I'm trying to say here is this router, even this interface and this interface is a member of area 4. It proves that this router is completely synced inside, immersed inside area 4. It is not a member of multi-area. This is not a member of multi-area. If it is OSPF, see this is a member of multiple area, right? This is OSPF. Member of area 2 as well as member of area 0. Whereas this one is a member of single area, only one area. Likewise, this is a member of area 2 only. Now, when you are forming adjacency with area 2 router and area 4 router, 4 and 2, you need L2 adjacency. That is where L2 adjacency is needed. L2 adjacency is, see, if you have L2 relationship, only then area 3 can form adjacency with area 2. Area 3 can form adjacency with area 4. Right? No. Why you are going to have additional router? You don't need additional router. You're not going to keep two routers. You are taking one of the router which is already in area 2 and connecting here. You did not add an additional router to be a border router. Why? No, there's no need. How can you say no? We are adding additional router. No, it's not additional router. This is a member of area 4. That is a member of area 2. Where is the additional router for adjacency? No, we are making use of one of the router in area 2, one of the router in area 4. You cannot call it as an additional router. You see, now what I'm going to say is a very big difference that someone should know what it is. In OSPF, if these two links, if two endpoints of the link is in different area, they cannot form neighbor. In OSPF, can they form neighbor? This is area 2, this is area 0. Can they form neighbor? In OSPF, it is not possible. See, in OSPF, if you have one end of the wire in area 2, another end in area 0, they cannot form neighbor. I think still you cannot get the picture. You look at this here. This end is in area 2. This end is in area 2. This end is also in area 2. That is why they form adjacency. Otherwise, they won't form adjacency if it is like this. OSPF will not form adjacency between these two. Why? Because this is in area 4, this is in area 2. Do you understand? Same link, different area. ISIS can form neighbor. What is needed for that? L2. If you have L2 adjacency, area ID it will not expect to match. You understand? If it is L1 adjacency, what is needed for forming adjacency? Area ID should match. I repeat, to form L1 adjacency, area ID must match. You see, for example, this is L1 and this is L1. They need to have same area in this end and same area, otherwise they won't form neighbor. But for L2 adjacency, if they are configured with multiple area IDs, they still can form adjacency because L2 adjacency will not focus on area ID. L2 adjacency will focus only on the system ID. System ID should be unique between sorry, on each device. Anyway, I'll come to that one later. Don't get into system ID because I have not shown you what is system ID. So what I'm trying to say now is for L1 adjacency to happen, the hello package should come from same area member. For L2 adjacency, that is not a mandate. The area IDs can be different. Now, what are the other things that you learn from this picture? You see, this is area 2, but this is acting like a transit for all other area 1, area 4, area 3. Without area 2, they cannot communicate, no? Fine. But what is important in area 2 is in the path you should have L2, 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 L2. So the networks gets distributed using L2. Between areas, it is only using L2. For example, if I will have only L1 here, now this cannot support as a transit area. Why? You don't have that database exchanged between areas. Why? To exchange the database between areas, L2 is needed. You see, the area 1 information will be learned here because of L2. But because there is the L1, that L2 database is not exchanged. I think I need to give you one more point before I tell this. You see, ISIs will maintain two databases. One is the L1 database. Another one is the L2 database. With L1 neighbor, it will only exchange L1 database. In L1 database, you will have only local area information. In L2 database, only you will have other area information. If this is L1, even though this router has got L2, it will not be received here. And here also it won't be received. Then this router will never know about area 1. Likewise, this router will never know about area 4 and 3. Isn't it? Because there is only one L1 here. Okay. Now, L1 routers uses LSP to build topology for local area. You see, L1 is only for local link state information. L2 routers are used to build topology between different areas. You said no inter area, that is L2. So in the border router, we always keep L1 and L2 so that L1 can form neighbor, L2 can form neighbor. So in every area, the border router, you keep both L1 and L2. Hmm. You can do it very well. You see, I understand what you are saying. If we don't have L1 here, if all are L2, will that work? Is that your question? Of course it will work. This area information will be distributed via L2. It will work. Then why are we having L1? That is a very nice question, which you will come to know in another pages, but I would like to give you a small hint. L1 maintains the routes of local area, and if I have L1 only router, it will not have route information given by other areas. For example, this router here, and this router here, and this router here will have the network information of local area. Then can I ping from this computer A to this computer B? Can A, B, and C ping each other? Yes. But no. How you say yes? I can say yes. Still, I have not explained to you how. Then how you can say yes? See, there is no route to reach B and C in this router area 1. There is no route. நான் சொன்னேன் L1 router local network மட்டும்தான் வச்சிருக்கோன்னு. If L1 router has only the local network, how will you ping C and B? How can A ping C and B? But the answer is yes, you will ping. I appreciate that answer. You will ping. But how? When there is no route, how? Very good. Bravo. Excellent. Very nice. You remember this point. So this L1, L2 router will generate a default route and give to this L1 routers. So that's a big advantage. You see, you don't need to configure stub. You still have reachability to all the other areas as well as the external. Yeah. CPU or memory, all will be less utilized. Integrated ISIS routing. Meaning why it is called as integrated, because it is supporting both IP as well as CLNS. In your Cisco router, if you want CLNS addressing support, no need to do any extra configuration. It works. Both. That is why it is integrated. So it uses its own packet data unit, protocol data unit to transport IP routing information update not sent in IP packets. So it is not going to use IP. See, you need to capture a ISI's header and see what I'm saying. Usually the protocol like OSPF, if you see, the protocol information is carried in the IP packet, layer 3 header. Have you seen OSPF packets? We have seen in OSPF classes. There you might have seen me showing header where you have area ID, router ID, checksum value. All those things are in the IP packet. Whereas here you have a separate portion called PDU. In that only the informations are exchanged. I'll show you when we do the lab. I'll show you, capture and show you. Now we still use the CLNS addresses in IP. That is why we configure something called net ID. I told you, no, we don't use router ID. To identify device, we use CLNS address, net ID, system extension IDs, and I'll show you when we go there. So we already spoke about this one. You see the core router. You don't need to run L1, L2 on every router. This can be L2 only so that all the multi-area informations are exchanged like this. And local area networks are summarized and sent. Mhm. So this minimizes the routing table when you do summarization. We know the advantage of summarization. I do not want to go more deep into it. As I told you earlier, the default metric on all interface is 10. All interface meaning what? You have a serial link, you have a fast Ethernet link, you have a gig, whatever the bandwidth of the link is, the cost is going to be 10 only. And next thing is the default narrow metrics are limited to 6 bits, 6 limited to 6-bit interface and 10-bit path metric. Meaning for the interface metric, each metric, what is it? 10. Now this 10 is written in binary using 6 bits. 1, 1, sorry, 0, 0, 1. This is 10, right? 6 bits. 10. 10. 8 plus 2, 10. Whereas for the path metric, 10 bits are used. To write this 20, which is path metric, 10 bits are used. All right, so 16 plus 10 bits. 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. I put one extra 0. This is 1, 2, 4, 8, 16. Yeah, 16 plus 4 is 20. So you got only 10 bit for path. You don't have more than 10. And 6 bit for interface metric. We call this as narrow metric. Narrow metrics are limited to 6 bit for interface and 10 bit for path. Whereas in Cisco, after this 12.0 means all today's version of operating system supports wide metric, which is 24 bit for interface and 32 bit for path. It's a very big number actually. Earlier it was only 6 bit for interface, now it is 24 bit. Earlier for path it was only 10 bit, now it is 32 bit. Now where it is used, wide metrics are used whenever you are doing IPv6 version of ISIS, segment routing, MPLS traffic engineering with ISIS. All this needed wide metric. I repeat, if you are doing MPLS traffic engineering with ISIS, you remember RSVP, ISIS. We go inside ISIS and we enable traffic engineering command. If you don't put wide metric, the traffic engineering command will throw error for you. You need to say metric wide. The default is narrow. When you say metric wide, what really happens? The number of bits given more for interface, from 6 it is given to 24. For path from 10 it is given 32. This is very important. The wide metric, many people ask question when they do some advanced concepts like segment routing. Why are we typing metric style wide? I have come across this question from many people. This is the answer. The number of bits to calculate the metric is more when you say wide, which is needed for traffic engineering, segment routing, IPv6, and etc. concepts with ISIs. This is an old story. You don't need to worry about this. They call even computer as end system. This is not needed. LZ level 0 and all not needed. Focus only on L1 and L2. L1 and L2. And between autonomous systems, they call this L3 routing. Between autonomous systems. See, between area, it is between areas, it is L2 adjacency. Within area, it is L1 adjacency. Between autonomous systems, they call it as L3 routing, but there is nothing called L3 adjacency. Okay, it's L3 routing. So here we have some similarities between ISIS and OSPF. I think there is no need to explain this thing. I want you to quickly go through this. I'll hold it for a minute. Right, so this difference also I have explained to you. Between OSPF areas, you will have an ABR, mandatory. The ABR router is a member of multiple areas. One is area 0, the other one is the non-backbone area number, which is mandate. In ISIS, that is not the practice. In ISIS, each router belongs to an area, one area only, exactly one area only. So extending the backbone is more flexible because all that you need is only L2 adjacency. Here you see the area ID is 2. How do I know area ID is 2? This is area ID. This is area 0. This 49 is just, a private usage of ISIS. This is not that important because now we don't have any difference between private and public ISIS. But you will see people always writing 49 when they write net ID. Advantage of integrated ISIs. You see, this is the biggest advantage. OSPF sends lot of LSA. See, they have very clearly shown the problem with OSPF in this picture. I love this picture actually. Type 1 LSA, Type 2 LSA, Type 3 LSA, Type 5 LSA, too many type of LSAs. Here it is not like that. Only two. L1, L2. That's all. L1 is between same area, L2 is between multiple areas. That's a big advantage. And this supports CLNP and IP And you can extend this ISIS to support multiple features by adding type length value, by adding some additional ISIS field. Okay, now what is the advantage of OSPF? OSPF has got these subtypes. We don't have those things in ISIS. OSPF metrics are calculated depending on the bandwidth, whereas here it is always 10. You can go and change, but auto calculation is OSPF is supported by multi-vendor. ISIS, you need to check. According to me, the standard companies, vendors, they support ISIS, all, but not engineers are trained with ISIS. That may be a limitation. OSPF, every engineer knows OSPF compared to ISIS. More engineers know OSPF. Okay, so information about OSPF, this type of training for OSPF, it is very well available easily, but for ISIS, it is quite rare. Right? So that's about the first chapter.